Interesting word problem on page 94, number 5. Dimensions of a rectangle are consecutive odd integers. So you need to know consecutive, you need to know odd, you need to know integers. Find the smallest such rectangle with perimeter at least 35. So that means that when I do perimeter, I have to do at least 35, and when you use at least, it means to do greater than and equal to, because I could be 35, or I could be greater than 35. So I'm looking at a rectangle, so I like to do a little sketch when I'm thinking about a word problem. And the sides are consecutive odd integers. So if this side was 5, what would this one be? 7. What if this side was 11? What would the next one be? 13. So consecutive odd integers, but I don't know this one is 5, so I'm going to call it x. This one, is it x plus 1 or x plus 2? Do you know? Do you know how to figure it out? All right, think. If this was 5, the other one was 7. How many did I add? 2. So to get from one odd number to the next, I always add 2. That works for even numbers also. So x plus 2. Those are the sides of my rectangle. So if I'm going to find the perimeter, I have to add up all 4 sides. Or I do 2 times the small side plus 2 times the longer side, right? And that perimeter has to be greater than or equal to 35. All I have to do is solve that problem now. So let's do distributive first. Well, first of all, 2 times x, just 2x, plus 2x plus 4 greater than or equal to 35. You know what to do next? Hope you said add like terms. 4x plus 4 greater than or equal to 35. How about subtract 4? All right, 4x greater than or equal to 31. What do I do now? Hope you said divide by 4. Uh-oh, now this is getting a little complicated. 4 doesn't divide into 31 evenly. It comes out to about 7.75. Can I say x is 7.75? No way. It has to be odd, and it has to be an integer. Well, 7 is odd. So if I need an integer greater than 7.75, how about 8? That's greater than 7.75. Would 8 work? Hope you said no. Why not? Because 8's not odd. So what's the next integer? Oh, 9. So 9. So x could equal 9. So this question was a little bit tricky in that when you solved for x, you really didn't get the answer. You had to go back to the stuff in the problem, think about what they were asking for. So one side is 9, and what's the other one? X plus 2 would equal 11. So hopefully that helped. Oh, back to a similar problem from geometry. Write the converse and then determine if the converse is true. X is greater than 1, then x squared is greater than x. What's the converse? I have to switch these 2 parts, right? Switch the if and the then. So the converse would be if x squared is greater than x, then x is greater than 1. Now I have to determine, is that true? So let's think of some values that I could put in for x. Suppose I put in 2. 2 squared is greater than 2. Does that mean that 2 is greater than 1? Yeah, well that one's true. All right, let's try it for a negative number though. How about negative 2? Negative 2 squared is greater than 2. Is that true? Well, 2 squared is 4. 4 is greater than 2. But is negative 2 greater than 1? No, it's false. And I showed that it was false by using what's called a counterexample, which is used a lot in Algebra 2. So hopefully that helps you with number 11.